So very good morning, students. Now in last lecture we have seen ferroelectric materials, and today we will see piezoelectric materials. So already I told you there are different types of materials: ferroelectric materials, piezoelectric materials, pyroelectric materials, and this will be little bit confusing which material is what. So if you will remember in comparison form, then your understanding will be written in very good fashion, and that is first thing to avoid confusion, remember in comparison form. And second, try to understand what is mean by exactly piezoelectric materials. In ferroelectric materials we have seen ferro, what is the meaning of ferro, and electric. So I just told you that hysteresis loop is there. So hysteresis meaning is lagging behind. Who lags behind whom? Polarization is created as you will apply electric field to that ferroelectric materials. Polarization will go on changing, and that will exhibit hysteresis loop. Okay. So that we have discussed in last lecture. Today let us see piezoelectric materials. You might have studied, but let us revise or just see in the detail. Okay. So what is mean by piezoelectric materials? So the piezoelectric effect was first discovered by scientists Jacques and Pierre Curie in 1880. See, he just invented in 1818, and still we are using this effect wonderfully in majority of applications, from house to the ships or sono ultrasonic equipments. So that also we'll see where these piezoelectric materials are used. But that was invented by Pierre Curie scientist. Now, both scientists, Jacques and Pierre Curie, found that if certain crystals were subjected to mechanical strain means what? Suppose rubber, you are stretching it. So this is stretching, and then you push it. Suppose you are pushing some table. So that action is there, that mechanical force you are putting, strain you are putting, stress you are putting. So materials which will produce electricity, or materials which will become electrically polarized. Now we have seen what is meant by polarization. Polarization is nothing but positive charge and negative charges. Two charges will displace with some distance d apart. They will create polarization. And materials will polarize. Material will become polarized means what? Positive charge, negative charge will be displaced with some distance d. And as there is a displacement, electric voltage will be produced. EMF will be produced, because positive negative charges are not coincident, but means at one point, but they are at some distance. So voltage will be produced, and therefore we can say that electricity will be produced when you will apply to the mechanical strain. To whom you will apply mechanical strain to produce electrical energy, electricity, or getting polarization? The materials which are piezoelectric materials. If you will use any material, you just go on applying mechanical strain, but you will not see polarization. Only in case of piezoelectric materials. So remember, piezoelectric materials means electricity is produced due to the mechanical strain. So principle of operation of piezoelectric materials or effect is the production of electricity by pressure. So this keyword you have to remember, because now questions will come that principle of operation of piezoelectric material is dash dash. Production of mechanical energy by pressure, production of chemical energy by pressure, or which electricity by pressure. So if you will remember this keyword, there will be no confusion. Now, when dielectric crystals are subjected to mechanical strain, it produces an electrostatic charge on the faces of the crystal. This phenomenon is known as piezoelectricity. So, what is? We are learning dielectric materials. So, it has to be dielectric crystals. All are types of dielectric materials. Ferroelectric materials, piezoelectric materials, pyroelectric materials are types of dielectric materials. So when dielectric crystal is subjected to mechanical strain, it produces an electrostatic charge on the faces of the crystal. Faces of crystal means sides of the crystals. faces means I will show you. If you'll consider cube, cube is having how many faces? So on faces, you will just see electricity. Okay, electrostatic charge. So this phase, so this is the phase, this is the phase. So consider this is a piezoelectric materials. Now this arrow shows that you are applying mechanical strain. So tension is applied in this direction and this direction. In short, you are just pulling these two phases. One you will pull to the upward and this below you will pull to the downward. So imagine that rubber you are stretching like that, you are putting this mechanical strain tension and you are pulling these two phases. So and as soon as you will apply mechanical strain, then charges will be created because positive charge and negative charge will be separated. Now here understanding is very simple because we have seen atomic structure, positive charge, central charge, nucleus we have considered, revolving electrons we have considered, and polarization means we are considering when such a materials are applied in electric field. Now see, we have seen polarization when such a materials will be applied in electric field. Means in that case, we are applying this electric field to the material. And as you are applying positive charge to this space, immediately negative charge will be coming here because what will happen? This positive plate will attract electrons. So negative charge will be here and this negative plate, positive charge will be here. So that is also separation of charges. That is also production of polarization. But what is the reason? Reason is the applied electric field. But here exactly reverse things happening. Here we are not placing such a materials in electric field. We are just pulling it mechanically, forcing it. So definitely you can just think that you are pulling your positive charge this side and negative charge this side. By pulling that material means charges will be separated and then it will constitute electric field here. Positive is here means this will be positive. If you will take a multimeter and you will measure the voltage across it by just pulling, then you will get some millivolts, microvolts. So that is the piezoelectric materials. Now this you can apply tension or you can do reverse way. So this is compression. Means you just consider rubber you are stretching and then you are relaxing rubber. So when you will relax rubber, then this face will be coming downward and this will come this way. So it is not rubber. Just to understand, I am explaining. These are piezoelectric materials. They are generally crystals, quartz crystals. Okay. So this is the compression. It will also create electric field. But see the difference? The difference in the electric field will be difference because the force directions are changed. Here this is reverse and this also reverse. So electric field dimensions or this signs will also change it. So this is another example. Means the same thing is shown here, but here positive and negative, but electric field will be produced like this, and you are just using this. Okay. So just watch this video to understand clearly. Okay. Just that is for the gap because if I will go on talking, I know where your mind will go on wandering. Can you hear sound? Students, can you hear sound? Hmm. Okay, watch it, watch Stand these whatever dipole moments are shown in one direction, the regions are called as domains. Okay, so these are domains. Domains are the regions in the materials in which you will see dipole moments are aligned in particular fashion. Okay, and when you will apply suppose electric field, these dipole moments will originate. Now earlier this you can just see, so this way you can understand in better. So now dipole moments are in this direction. Here dipole moments are in this direction. So this is a region where dipole moments are originated in upward. So these are called as domains. These domains is having dipole moments in reverse direction. Now when you will place such a material in electric field, what will happen? Dipole moments are nothing but charges, positive charge and negative charge. So this negative charge will get attracted towards positive. So whole dipole moments will originate parallel to the applied electric field. Okay, so there is called as orientation and reorientation of the dipole moment. So if you will apply a AC wave, go on changing a sinusoidal wave, so these dipole moments will change this way, that way, this way, that way. We have seen in 1 second 50 hertz frequency means 50 cycles, and 50 cycles means how many times these will go on changing. So that I explained you yesterday in last lecture with ferroelectric effect. Now you can observe on the screen time is changing. So here when time will come near to 15, immediately we have to press stop. Okay. So that way you will just see what will be recording. I will post in group. Now see whatever I told you, I just explain you with video. Okay. First, I told you with the slide what is happening, how electricity is produced by applying force, and here you are visualizing it. So, if you are visualizing, your memory becomes for long term. Okay, so that is the intention. So, when we see pictures, it goes in our memory for longer time. Okay. So this is the piezoelectric effect. I hope